Hello everyone, welcome back to Maxim Automation. Today in this video, I'm going to discuss the third principle of solid, which is the Liskov Substitution Principle. We'll discuss what this principle says and how we can implement this in our framework. So first let's talk about what this principle says. It says that objects of a superclass must be replaceable or interchangeable with objects of its subclasses without breaking the code. This principle was initially introduced by Barbara Liskov. It is based on the concept of substitutability, which means that the objects of subclasses can substitute the object of a superclass or base class without breaking the code or program. Now, let's understand this principle by the example. So let's say that I have a class here called as deserts, and this class contains one method to calculate the calories per gram in desert, which takes gram value as input and then prints the total calories by multiplying with 10. Then the second method, which prints the room temperature melting point of the desert, and here it prints the 20 degrees Celsius as melting temperature. So let's say this is a base class called deserts, and we can have multiple types of deserts. So if I get a new type of desert, then I'm going to create a new class for that. Let's say the new type of desert is ice cream. So I'm creating a new class as ice cream. And because ice cream is a desert and we have is a relationship between these two classes, so I can inherit desert class here. So ice cream is a subclass and the desert is base or a superclass. And now for ice cream, I can have a different implementation to calculate calories. Also, I can have different implementations for getting the room temperature melting point. So let me override these two methods from deserts class to this ice cream subclass. And now let me add the different implementation for calculating calories for ice cream. Let's say per gram calorie in ice cream is 15. After that, I can implement the get room temperature method for ice cream. And let's say the melting temperature for ice cream is 10 degrees Celsius. So now I have overridden these methods from base class and provided a different implementation for this ice cream class. Now let's say now we get a new type of dessert, which is cheesecake. So in that case, I can create a new class again for cheesecake. So I'm creating a new class here as cheesecake. And because cheesecake is also a type of dessert, and we have again is a relationship between these two classes, so I can inherit desert class here, where cheesecake is a subclass and the desert is a base or superclass. And now for cheesecake, I can have a different implementation to calculate calories. Also, I can have a different implementation for getting the room temperature melting point. So let me override these two methods from the desserts class to this cheesecake subclass. After that, let me add the different implementation for calculating calories for cheesecake. Let's say per gram calorie in cheesecake is 20. After that, I can implement the get melting point method for cheesecake. And let's say the melting temperature for cheesecake is 30 degrees Celsius. So now I have overridden these methods from desserts class and provided a different implementation for this cheesecake class. Now the ice cream and cheesecake have their own implementation of the base class methods to calculate the calories and to get the melting temperature. Now let's say I again get a new requirement for a new type of dessert, which is a pie. So for that, I'm again gonna create a new class for new dessert type which is basically a pie. So I'm creating a new class, and because pie is also a desert, and we have again is a relationship between these two classes, so I can inherit desert class here, where pie is a subclass and the desert is a base or superclass. And now for pi also, I need to provide different implementation to calculate calories and to get the melting point temperature. So let me override these two methods from deserts class to this pi subclass. After that, let me add the different implementation for calculating calories for pi. And let's say the per gram calorie in pi is equal to, let's say 25. After that, let's go to another method to print the melting point of a desert. Now, we have one catch here because it's a pie and pie cannot melt at room temperature because pie can be served as hot, so it's not gonna melt at room temperature. So I don't have an implementation for this method in pie class. So what can I do? I can throw an exception here saying that new unsupported operation exception and can pass the message that pie does not have room temperature melting point. Now I have three types of desserts created: ice cream, cheesecake, and pie. And all three inherits the base class desserts. So this is the class structure I have. Now let's see whether it follows the Liskov substitution principle or not. So here I have this main class where I have created the object of the desserts class and then call the method to calculate calories and to print the melting room temperature of a dessert. Now let me run this test. Here you can see it worked and printed the total calories and the melting point. Now, according to the Liskov substitution principle, objects of a superclass must be replaceable or interchangeable with the objects of its subclasses without breaking the code. So now let me replace the object of base class with its subclasses. And ice cream is a subclass of desserts. Currently, it printed 20 for both calories and melting room temperature. Now, if I run this again, where I have substituted the object of base class with its subclass, then the output will be different. But that's absolutely okay because the code should not break. Here you can see it worked and printed the total calories and the melting point. Though the values are different because they are the values for ice cream, but the code did not break. Now let me replace the object with another base class, which is cheesecake. And let me run this again, where I have substituted the object of base class with its another subclass called cheesecake. Again, the output can be different. That's absolutely okay. But the code should not break. Here you can see it worked and printed the total calories and the melting point. Though the values are different because they are the values for cheesecake. But the code did not break. Now let me replace the object with the third base class, which is pie. And let's see whether it follows the Liskov substitution principle or not. So I'm going to run this code again. The output can be different based on the pie class implementation, but the code should not break. Here you can see that we got the exception. Although it printed the total calories, but we got an exception of type unsupported operation exception because pie does not have room temperature melting point. So here this class violates the Liskov substitution principle because when we replace the base class object with the subclass pie, then it broke the code. So now let's see what we can do to make our classes to LSP compliant. Now as we know that few desserts can melt at room temperature while others won't. So we cannot say that all desserts will have the melting room temperature. In that case, we can divide our desserts class further into two different classes, where one class will be for frozen desserts, which can melt at room temperature, and then the second class, which is for hot desserts, which can be served hot and don't have any melting room temperature. So let me first create a new class as frozen deserts, and then the other class for hot deserts, which can be served as hot. Now let's go to the deserts class. And because now we know that not all deserts can have melting room temperature, so I can remove this method from here. And then let's go to the frozen deserts class. Because frozen deserts is a type of deserts, so it can inherit the deserts class. And then I can override the method for calculating the calories for frozen deserts. Because now we have only one method available in deserts class. And because we can have melting room temperature for frozen deserts, so I can create a method here to print the room temperature melting point. Now let's go to the hot deserts class. Because hot desert is a type of deserts also, so it can inherit the deserts class as well. And then I can override the method for calculating the calories for hot deserts as well. Now for hot deserts, we have only one method to calculate calories. And for frozen deserts, we have another method to print the room temperature melting point. Now let me go to the different types of deserts. As this is a type of frozen deserts, so I can update the base class of this subclass as frozen deserts. Then ice cream is also a type of frozen deserts, so let me update the deserts here with frozen deserts. And then the last one is pie, which is not a frozen desert. It is a type of hot desert. So here I can replace the base class with hot desert. And now because hot deserts does not have any implementation for melting room temperature, so I can remove this method from this pie class as well. So this is the class structure which I have created to make it compliant with LSP principle. Now let's move to the main class again. And here, now I don't have melting room temperature for all the deserts. So I can update the object from deserts to frozen deserts. And now, because the pie is not a type of frozen deserts, so it won't allow me to create the object of frozen deserts by using pie. Let's replace the object with its subclass, which are cheesecake and ice cream. Then this will work without any code break, because now we have a melting room temperature method available for all frozen deserts. So I can substitute any subclass object of frozen deserts class. And I can say this is now LSP compliant. Now there are some rules regarding method signatures, return type, preconditions, and postconditions that we need to follow to make sure that our classes are LSP compliant. So the first rule is that we cannot have different return types for override methods in both super and subclasses. Here, when I change the return type, then it throws an error because we cannot change the return type of the override method. This is by default handled by the programming languages like Java or C#. But just to let you know that this is one of the rules which we need to take care of. Then the other one is that we cannot have different signature or argument types for the same method in super and subclass. Here I cannot have another type of this argument either in super or base class. Argument type or signature must be the same for all overridden methods. After that, the third rule is that a precondition should be satisfied before a method can be executed. Let's look at an example here. Let's say if there is a precondition that the gram value cannot be less than or equal to 0 and cannot be greater than 100. If it's true, then it throws an illegal argument exception. So when we have this kind of precondition check in superclass, and also we have the precondition in subclasses as well, then we can create a wider range in subclass. So here we have increased the range from 100 to 200, which is LSP compliant. But in case I'll narrow the range from 100 to 50, then this is going to violate the LSP principle, because superclass object expected the value from 0 to 100. And when we replace the superclass object with its base class, which narrows the range from 100 to 50, then it is going to throw an exception. And then the fourth rule is related to the post condition. Let's say that you're going to return a value from the function based on some checks, where you can put the condition like, if the gram value is between these ranges, then you will return the value. Let's say the post condition range in superclass is from 0 to 50. Then to make your class LSP compliant, you can narrow the range. Let me update the range from 50 to 20. In this case, the class is LSP compliant. But if I widen the range, let's say from 50 to 100, then this is going to violate the LSP principle. So this is how you can implement the LSP principle while designing your classes or methods. I hope you liked it. Please put your comments in the comment box. Also, please do not forget to subscribe to the channel. Thank you.